of you attended our talk last year? Okay, good. I hope I can offer some more this time. If not, there's a very diverse audience here. And from my background at Census Bureau as a data dissemination and my previous life being supervising the ACS data collection, I've noticed that our data users come from very different backgrounds and project needs. So it's very hard to address specific uses right now with so many of you. So one thing I want you to take from today, along with so many knowledge and skills we would like to share with you, it's my contact information right there. I'm your local resource from the Census Bureau. I serve the New England area. So any question, any interaction with the Bureau you need, reach out to me. I may not know everything, but the good news is I may know who knows, and I can go after that person for you. So that's one of my services I can offer to you. So today I am pleased to have Jonathan and Len with me, and when I pass back to them, you'll see what great tool they build from our public data and how useful it can be to all of you. So what I plan to provide to you today is a quick background on the American Community Survey and some of the tools we can offer to you, such as the Census API and the CD SDK. So before I go there, first thing is we are on social media. Let's start our conversation. So if you have a phone right now, if you're on Twitter, Facebook, Instagram, join us there. I already posted about you guys, took a picture of you guys, and go there and start a conversation. It'll be great. And before I go into the really technical content here, not that technical, I have a warm-up quiz. So let's get talking here. And you can guesstimate, which I doubt you will, as you're all data scientists, right? What was the unemployment rate for the nation in the past month?
4.4%.
You are not allowed to participate. Anyone? You can guesstimate, serious. I just want to warm up. Go ahead. 5%, okay. What's the source of the data? Yes, and where did they get it from? I heard Bureau of Labor Statistics. Great, kind of right. So let me show you why I like to show this, okay? It's really important to give you an idea of who we are as a Census Bureau. So just, oh, the view is kind of weird here. Okay, here we go. Hope you can see this. So 4.4, so Jonathan was right, and you're almost there. But look at this. The current population survey is conducted by the Bureau of the Census. So yes, they do get the credit, but we do the work. And that's true with the Census Bureau in so many instances. We are known to be out there every 10 years collecting the census and not expected to really be around for the other 9 years, still collecting our paychecks, which would be great, but it's not true. We are collecting over 130 surveys every month of every year. From measuring our population, the characteristics of a population, measuring our business community, our economy, and our geographies. So there is just so much out there that will take a lifetime to learn it all, and another life just to work on it. So hopefully I can scratch the surface of some census data knowledge today, especially the American Community Survey, and you'll be able to interact better with our resources. Let me go back to my presentation. You see I'm going back and forth. Here we go. So our outline, quickly, I have a short part of this presentation. First, I'll go over the basics of the ACS. What are the things you really must know? So when you're looking at our data or interacting with it, you can really make good judgment of what is the quality of what you're looking at, like how this data comes to life. And then I'll show you examples of apps that were created using ACS data and some other data that we have. I'll take you to resources for developers, which is a great part of a website. Show you quickly our Census API. And I've heard a lot that a difficulty that our users experience with our API, it's identifying variable names because we have our own terminology, our own language. Hopefully I'll share some tricks with you today. And then I'll take you to, why that looks so weird? I'll take you to our CD SDK. That's what we should be showing right there. I don't know why it's looking so odd. And explain to you how to use a query builder. So first, in regards to the ACS, I mentioned we conduct a census every 10 years. Two purposes. Do you know why we conduct the largest peacetime operation in the country? Yes, Article 1, Section 2. Why do we need such an honorable spot in the Constitution? Nope. Sorry? Yes, right. That's why it's so important. Census data is used for reapportionment, redistricting. Thinking of the two purposes, when we're talking about the decennial census, and think of this about the level of data you can get. Talking about geography, we need data down to block level. You get it from a census every 10 years. About variables, that's a different story. How much do we really need to collect in order to get the job of reapportionment and redistricting done? Number of people. So you will get that from a census. We also need some characteristics for the voting districts when they are redistricting. Race, Hispanic origin, marital status, age, whether they own or rent a home, whether it's vacant or occupied. That's what you get from the decennial census. So when I get a call, can I get median household income from the census? Well, from the Census Bureau, yet. When we talk about programs, no. So how do we produce the great socioeconomic statistics, the housing statistics, the very rich data we love and use, if it's not from the decennial census? So well, after 2000 census, we started in 2005 the American Community Survey. That used to be the 2000 census long form. So we send a short form with the basic characteristics to everyone. And we send a long form to a sample, 1 in every 6 households. We got it. Great data, awesome, really rich. Published 2001, 2002. People were excited. Didn't take long until we started hearing, oh, this is old. I can analyze my community, like things are shifting, changing, communities are changing, like fast pace. What can I do? So taking that into consideration in how our communities were getting more data-driven, for a good reason, we started the ACS. So we got the long form, gave it a new name, a new look, we tested questions, and start conducting every month of every year. So since 2005, it's a random sample within counties to ensure that every community get data. And every year, new data is released. I'll cover the release schedule with you in a little bit. But just know for every city and town, if it's 300 people, you get ACS data. You get ACS data down to a level called block group. I'll cover geography in a little bit. And these things will be important because when you go into the world, other tools out there, knowing the background of the ACS would definitely help you. One thing to keep in mind with the ACS, it is a sample. So in many of our tools, you will interact with margin of errors. That could be a good thing, maybe not a good thing in some instances. While with the census, you're looking at 100% count, so no margin of errors. Okay? Another thing is when you're looking at census data, you're analyzing a date and time. April 1st of 2010. That's what the picture of the population was that date. While when you're looking at ACS, it's not associated to a date, but to a period of time, a 1 year or 5 year period. I'll go over that in a little bit as well. So going into the ACS content, actually, let me step back. Let me warm up a little bit more. Can you guess what is the sample size for the ACS in addresses? The initial sample of addresses that we get random selected per year. I'll put something in context here. The current population survey for the BLS, the one we hear every month in the news, we just talked about, employment rate. When we conduct that for the BLS every month, our annual sample is 100,000 households. What is the ACS sample? That's a good guess. We usually get something much lower than that. Yes, it's about 3.5 million addresses that are selected every year to be in the ACS sample. Taking consideration, we're going to interview everyone in the household, so more interviews than actually addresses. But at the same time, you're dealing with addresses that could be, because it's random, it could be vacant, it could be demolished, it could be empty lot. So all of that is in our master address file, and it's just random selected from there. Okay, so let's move into content, and this is what gets really important here. The ACS cover a really a variety of content. It's not as specific as a lot of our surveys, construction survey, health survey, labor force survey. We are covering demographic, socioeconomic, and housing in many instances. So you would find a lot that you can cross and a lot of different pictures you can draw from it. What we see to be important for people to know is which areas they can go to. So starting with the basic content of the ACS, which is divided in social, demographic, economic, and housing. It's a good point to know what's there. These are just the basic topics. Within each topic, you see more variables associated with it. So the best way is really exploring our website and learning about the ACS. That way you don't spend like 8 hours reading documentation, trying to figure out if reading literacy is there, when it may not be, and you just learn that after reading. Going to, especially the American Fact Finder, can tell you right away what variables are available or not available from the ACS. Moving on to geography, and just one thing, you don't need to worry too much about a lot of notes. These slides will be available to you after, as well as a recording, so you can always refer to this. And this is a pretty ugly slide. I've been telling myself the last 5 years I should do this better, but I don't think our geographers would like that, so I'm just staying with it. These are just the most popular level of geographies we release data for. And a lot of it you're familiar because we learned about states, we know where the nation is, but some language here is very specific to the Census Bureau. And learning these terminologies can really keep you in the right direction for accessing data. So I'm just explaining you something I witnessed recently in Massachusetts. This organization decided to hire professionals to analyze foreign-born population for every city and town in Massachusetts, because they were serving that population. They put this beautiful report together. I was showing up at the organization to conduct a training for their grant writers. Saw the report. It was dated ACS 2011 data set. 2011 was one of the years I supervised ACS. I was like, awesome, I know how my staff worked hard. This is really good data. I was looking at the report. They did a beautiful job analyzing ACS. The visuals they provided, the graph, the charts, the map, outstanding, until I got to the appendix. I put the report in the trash right away, and it had to do with the choice of geography. The way they chose cities and towns in Massachusetts didn't give them the full boundary of the cities and towns. So if they're saying there's so many foreign-born in Framingham, they're using half of Framingham they didn't even know because they chose the incorrect geography. So geography is base. So when you're pulling census data, picking that right geography is important. So let's start with zip codes. A lot of you analysis for zip code. In the census language, we use the term zip code alone for business data. If that's what you want, easy, zip code. If you want data about people from the ACS, our language is zip code tabulation area. So if you bump into ZICTA or that, it is the zip code. This is the same number. You may call it for the exact same number zip code. It's just their terminology. And when you go into our API, you see that there. So I just want to make sure you're familiar with that. I'll go now to the state level with you, and I'm going to talk about two things here that you can see from the state level. One is called the public use microdata areas, and one is places. The microdata areas, or PUMAs, we like to call, is what is going to be really important for you to understand when you're using things like data.world. PUMAs are geographies that the Census Bureau create that to allow you to access ACS microdata sample. It's basically raw files, raw individual records. They are pulled and aggregated, and you can create and cross-tabulate. They'll talk more about that. I'm not going to be expanding on that. But these geographies are areas with 100,000 people or more. So think of Boston, where we are. Boston is divided, I think, in 5 PUMAs. But if you think of an area of small towns in Massachusetts, you're looking at a few towns combined to form one PUMA. So you'll be able to do a lot when you're using PUMAs in terms of variables you can cross and tabulations you can create and analysis you can perform, but you're limited to geography. You can do state level or PUMA level. So just become familiar with this terminology. If you're not, this is what you're going to see in data.world, right? Okay. Second is place. Place is how you call cities and towns, yes and no. If you call our headquarters right now, our data center will say, oh yeah, cities and towns, places. Well, New England's pretty special, such is the case for New York, New Jersey, Wisconsin, and Alaska. Our cities and towns are not places. So this is what the folks writing the report did. They went into places, grabbed all cities and towns from Massachusetts. The boundaries are not necessarily the boundaries we expect. Our cities and towns in New England, New York, New Jersey, Wisconsin, Alaska are called county subdivisions. Divisions of counties, we don't have county governments. Every city and town have some form of government. That way, in the data world, that's something that's important to know. You pull from places. If you don't see a map to verify the boundaries, what you're expecting, you could be talking about half of a town, or maybe a town and a half. So always be aware of that. Places for every other state, but not for New England, New York, New Jersey, Wisconsin, Alaska. Terminology is county subdivision. And sometimes we call it minor subdivision too. So going below that, ACS data goes into geographies below county level, or we can even say below city and town level. And that's what gets really important about the ACS. Not only the amount of topics, but also the level of geographies it takes you which we call the block group level. So census tracts are divisions of counties. In our geographies, they were created to allow you analysis of smaller areas. They are somewhat very stable over time because they are based on physical boundaries as well as population threshold. So they're boundaries we just review every 10 years when we're doing a census. And if the population has gone above the 8,000 threshold, we may split that tract into 1.1, 1.2. But still we have a reference. In the past was track 1. So it will facilitate your analysis over time, trends over time in that aspect. Going down below tract level, you work with block groups. It's the same thing, only reviewed every 10 years, the boundaries. You have a population threshold between 600 and 1,500 people living in a block group. That's the smallest level of geography you can get ACS data for. They issue with block groups, and it's a warn most of the data scientists. Before you make a final decision that's the level of area you want to analyze, make sure you have data available for all areas, and the data has quality. In many instances, data could be suppressed from block group level. So let's say you're analyzing the Haitian population in a block group in Boston by their income. So the minimum population of block group is 600, right? And let's say you only have 100 people who are Haitian there, and from 100, only 50 are now working and producing income. That population is so small that due to quality and confidentiality, we will suppress the data. So those are two things that will cause us to suppress data: quality and confidentiality. So if you end up with blank results, that could be an issue there. How detailed you're getting and to a small level of geography you're getting to. Any questions about geography before I move on? No. Go ahead.
Do you have blocks for bigger areas like greater Boston area, greater Houston area, greater New York area?
You're talking about blocks?
No, not blocks, actually like a bigger,
Oh, the metropolitan?
Yeah, that's right.
Yes, so there are so many geographies. Again, this is just a few. So you can work from metropolitan areas, urban areas, rural areas. It's just some of the geographies are not stable in the sense that boundaries can change. So for one-time analysis, it may work well because you have the boundary. But if you're looking at a trend over time, you really need to make sure you're comparing apples to apples, that the boundaries haven't drastically changed. So you're not saying, oh, wealth is increasing here, or maybe income disparity is increasing, when you're talking about two different geographies over time.
Well, but let's say if you're only interested in one point at a time, so what would be the correct level?
You'll be fine, yes. Then you'll be fine to use. I would go to any of them. Just the block group is where I'm more careful because suppression is higher. You may end up not getting anything, depending on what you are calling for.
So it would be like a combination of several counties, or?
What?
I think it means CBSA. Yeah. You're looking at Greater Boston area?
Oh, the Greater Boston area? You can go, the Greater Boston area, there are a few things you can look when you go into the website in ways that we call it as a geography. And if you're very interested in that, call me, because depending on the one you select, you're not going to get certain data sets. So ACS are available for a few of these geographies. Then for the other ones, you're only going to get business data. It gets a little bit confusing in that aspect. And that's what I see in the research world a lot, especially with universities here. They are set with a geography, but they want ACS. And I was like, you will have to change because this geography with this boundary, we only release vintage 2007. You don't have 2015 vintage published for this. So this is the little things that you would have to pay attention and make that decision before you're like, okay, this is what I'm doing. Okay? Go ahead.
Two quick questions. So I was working with some ACS data a while ago. My understanding at that point in time is the ZCTAs are not always equivalent to zip codes. And there's no publicly available crosswalk or mapping or subdivision.
There is. There are several. What happened with the zip code tabulation areas, we don't own the geography. It's a post office geography. We have to do our best to mimic that geography. And if they remove an address street, it doesn't mean we're going to republish the entire data. So we do our best. So in some areas, you see they're not an exact match. And not only that, for the business, the way we separate is some zip codes, it makes sense that a full building, like a really huge building in New York City, it's its own zip code. We're going to publish because there are businesses in there. But it doesn't make sense to publish a zip code for population data. No one lives there. So we collapse into the ground zip code. That's why we separate zip code for business, zip code tabulation about people. and limited number of data sets available for zip code too. So your best bet, you see the string in the middle? And if you take in consideration places and county subdivisions, this is where you're going to find the majority of your data sets available for. Like basically everything we publish, down to the block group and with some suppression in there.
My understanding is that there's not 100% coverage of the entire that's just 3 places. Is that correct? Like if you say, like, give me all places, that's not necessarily meaning 100% coverage.
Okay, let me rephrase this. We have 100% coverage. It's just the way status of geography is set up, it can be challenging. So if you look for all places in the US, with areas like New England, you're gonna get not exact boundaries in some cities and towns. So how you do, let's say, compare all cities and towns in New England, Massachusetts against cities and towns in California. I would go pull my cities and towns from places in California, then I'll go into county subdivision and pull all of my Massachusetts cities and towns. That's how you're gonna get exact boundaries. I wish it was more straightforward, but again, I don't want to extend too much, so I'll just move on. Again, I'm your local resource. You give me a call, I'm more than excited to talk about these things, and I get so excited that my accent gets worse and thicker, and you see I can keep you on the phone for hours. So just be careful what you wish for, but give me a call. Here we go. So I have some notes on that for you when you get the slide. Okay, let's go into data sets. I can move on, give these guys a chance to introduce you guys to the great universe they created. ACA's data sets, so we're talking about primarily 3 data sets here. First, what we call summary files, and I'm just throwing you a lot of census language because you're going to have to kind of deal with that when you go into our stuff. Summary files are the ACS that are published every year, 1 year and 5-year estimates. So 1 year published every September for areas with more than 65,000 people or a universe of more than 65,000 people. So Boston has over 600,000 people. But if the universe of your tabulation as single month unemployed in Boston and they are less than 65,000, that's not your data set. And these are types of calls I get from data scientists and developers. Why I'm not getting any results? Like, well, your universe is below 65,000. You need to go to a 5-year estimate to be able to access that information. So 5-year estimates are available for all areas, down to a block group. And they are published every December around the first week of December. A lot of things could be said here and how to compare, do not compare, how to look at data analysis trends over time, like 5 years, be careful to not use overlapping years. So you can compare 05, 09 to 11, 15, but if you compare 10, 14 to 11, 15, you're talking about 4 out of 5 years, exact the same sample. You can't tell a difference if your population is getting more excess health insurance or not. So be very careful when choosing your data set you're going to get your data from. It's based on geography and universe. The next one I want to mention, and I talked a little bit about, is the public use microdata sample. It's one of my favorite data sets because it allows you a lot of flexibility when it comes to accessing variables, recoding variables, very detailed level, because you're operating from individual records. There's many ways to access this data set, and you're going to learn about one today, so I'm not going to even go any further into other ways of accessing. But keep in mind that the only limitation here is to do with geography. So the sky's the limit when it comes to how you can explore your variables, how you can recode them, cross-tabulate them, analyze them, mash up them, but geography, it's your limitation here with 3 levels of geography, right? So I'll let them talk more about that. Or anything you would like me to add?
No, I think it was great.
You will add more? Okay, sounds good. So let's just go into some popular data applications. Have you guys seen the Census Business Builder? Ooh, I got one, yes. Okay, so this is what I want to show you. I'm just going to go to, let me make sure my hyperlinks are working. No, they're not. Here we go, that's okay. I always have a website ready to go. So the reason why I want to show you the Census Business Builder, this is an application that was developed using the Census API. From the Census API, you use ACS data mashed up with our economic programs data about business, data set about businesses. Also mashed up with our Geo API for our shapefiles, our geographies. And also we included data we purchased from Esri. It's built on the Esri platform and is a great visual of data and things that people can do because the API is free, it's available. You can go there and have fun. But let me just give you a quick idea of what this can do for you in a data mashup example of different data sets from our API. So if I want to open a full-service restaurant in Boston, I can say I want to open a restaurant here. And I'm not going to even go for my location. I'm just going to say Boston, Massachusetts. And we could go straight to a report, but I'm going to show you quickly the map. Just minimize this for now. So the level of geographies are being called from our Geo API, right? So you can go from a state level to a track level here. We should call it a neighborhood, but I think we changed our mind because it's not really a neighborhood. And from here is where you access all the information and you choose the industries that come from our economic API, from our businesses API. Here you would go to select variables, and there is a mashup here too. So for my potential customers is where you explore ACS data. So you could go to socioeconomic information, say I want to know medium household income for the area I plan to open my business. Could go down to a track level. But I could also go into the system is calling the business API and find out information about other restaurants in the area, number of employees, sales receipts, all of that. And the last one, it's calling the ESRI data set for consumer spending data. So this is just one of the many, many tools we have out there. They are now interacting directly with the Census API. And I just gave you a list, and they all have hyperlinks, so when you get a copy of this, the first column are all Census API based. This column are great, excellent data tools here for you. Just take your time to explore. Highly recommend Census Reporter, not a Census tool, amazing. And it's a great way to interact with our API because you can research the variable name here, and then you just put in your URL string. Easy like that. So let's move on, try to go quickly here. Let's go into the Census API. First thing you see is our API has several data sets. Take your time to explore. ACS is there, and that's our topic today. So instead of just staying here in the PowerPoint, I'm just going to take you online right now and get more exposure to, sorry. I know my picture is awesome there, right? Here we go. So from census.gov, we have a page that's dedicated to developers. It's census.gov/developers. From this page, you can, that's small. Let me change the view here. Here we go. You have opportunity to check all available APIs from here. From each API, such as the ACS, when you click on, you see there's more information about the API, the different years available, as well as you can get summary file data, subject tables, they're called S tables. Data profiles love this data set. It matches up a lot of all the ACS variables in a good way of, you can create a profile of any area. And then you have the comparison profiles. What's a good resource here is you have all of this, and you can say, well, where I'm going to find my income that I just want a medium household income, period. And it gets really complicated then. So there are a few things we did. First is go straight to Fact Finder. Have you guys used Fact Finder? Okay. So you're not going to use Fact Finder here for the purpose we usually people go in for. What Fact Finder is a good way to provide you that variable name from to the Census API. Let me just zoom in here. Is by searching. So let me go to income. And it'll give you all the income tables regardless of geography. And as soon as you find a table that has that pointed statistics you want, let's say here, medium income, you know that this code here, S1903, it's all you need to know. This is what you're going to be starting to call the name variable. It's a subject table, it's an S table, and you see in the URL string how that plays out. So let me go back to the developers page, right here, up. And you have a list of all the variables available from each data set here, from the geography to all the names. So you can research that here for any API data set we have. Okay? So using fact finder to find out that table ID for your URL, it's key. So let me show you right now one thing here before I introduce you to our CD SDK and move on to data.world. It's the URL, the way you're going to call our API, you need first to request a key. So in census.gov/developers, there's right there a place you say request a key to access our API. And the URL string, it's always the same until data slash, oh, sorry, I'm in the wrong screen. Here, until data slash, you're always going to add the ACS year you want to call, the data set, if it's ACS 1 year, 5 year right here, and then you're going to get the name variable. This is where the S1903 would fit. And from that HTML list of variables, you would find exactly the S1903-what means medium household income. In one call, you can call up to 50 variables, and you can call up to 500. You can call our API 500 times in a day. So these are your limitations here with our API. Quickly, CD SDK, and we can move from there to data.world. So here on the CD SDK page, it's a place I definitely think you all should visit. Our documentation is great, and it helps you work through the challenges of knowing the variable names, especially with our query builder. Hopefully it will work well in this browser. I've had a few problems. You have here the data sets you can call. You have the year. You can choose a level of geography. So let's say state. And go for Massachusetts. And I can choose, I can't pronounce that word and I practice, so I just call variable name, just saying. So you can choose, let's say I want to do just age. And my geography within counties, I'm just going to be quickly, and you update data, and you're going to get a request. You are going to get 3 formats of the way it's going to return to you. The map's not showing. So you have a JSON response, as well the sample code here. So the CD SDK is a great start for you to interact with Census data. We have our Census modules right here to give you a lot of code that was already created. This is open source, so anyone can create anything, can put it in there. As well, there are several other APIs here that we partner with other federal agencies. So explore the HUD's Opportunity project. There's a lot of good stuff here, and I really recommend this as a resource for you. I'm going to now let data.world take over and introduce you to how they got Census public data and turn into a great resource for you. Here we go. Thank you, guys. This? Oh.
Quick little switcheroo. Hi, everybody. My name's Jonathan. Hi. My name's Jonathan. I am a data scientist and knowledge engineer at data.world. First, quick show of hands. Who has heard of data.world? Sweet. Okay. That's more than a few people. I'm very pleased to know about that. I would like all of you, before the end of the day, to sign up for data.world because we're going to show you how you can access some of the cool information that Alexandra was walking you through in a programmatic way, or not necessarily programmatic, but as an interactive way. And data.world is, as far as I know, the only platform where you can interactively use SQL to query ACS data directly and join it to your own geocoded data sets live within our platform. The first thing I just want to say is data.world, I received a grant in summer of 2016. It was a National Science Foundation fellowship to work with the U.S. Census Bureau. And when I started that grant, I did a little bit of an audit of all the different distribution channels that currently exist for the American Community Survey. Some that are provided by the census, but also others that are not. Census Reporter is one that Alexandra spoke about. There's also datausa.io. That's another really good one. It wasn't lost on me, the vast array of methods of getting ACS data. And I didn't simply want to clone what the census already provides. I didn't want to do something that others have already done. So I wanted to think of what's new, how can I present this in a new way, and make it, and hopefully address the needs of new users who currently are unsatisfied with the myriad ways that you can access the ACS. So my mission was to ingest the American Community Survey into data.world in new formats to increase visibility and usability with new cohorts of data users. And this is something that Alexandra already hit on. So ACS data exists in two broad categories. There's the summary files. Those are the pre-tabulated population estimates by geography. It's practically every geography you could possibly think of, from the entire United States all the way down to those block levels. And the summary files are fantastic. They have a lot of pros. One of the pros, I would say, is that there's no compute time. You know, it is the number. There are thousands upon thousands of population estimates at your fingertips at the census. And if you're looking for something as concrete as the number of Hispanic teachers in a given zip code, you can just go look that information up, and it'll show you the adjoining margin of error. What the microdata is useful for is when you're looking for something that's a little bit more, there's more minutia. So if you're not only looking for the number of Hispanic teachers, but Hispanic teachers who live in a certain geography, who also have a STEM degree, and who also drive more than 2 hours to work every day. You know, something like that. The census has tried to think of the most popular population estimates you might be interested in, but those microdata files are what you're going to need to use in order if you want to tabulate your own population estimates. And the way that you use those is every single record is given a weight value, and then so all you have to do is find the records that match the population you're looking for and tabulate all those weights. You just total them up. So it's actually a really simple process to use the microdata files. And then you use a formula to estimate the margin of error. So there are these two different types, and I went about them in different ways. And I'm going to talk about both of those briefly. There's actually a third, by the way. It's a hidden one that's not listed up here, and it's the shape files. So if you're doing geospatial, the census provides shapefiles. And I actually didn't touch that because I'm not a geospatial expert. So the first thing I want to talk about is this American Community Survey microdata, or it's called the PUMS for short. That's the Public Use Microdata Sample. And so in addition to tabulating your own custom population estimates for populations of very detailed groups of people, you can also use this because it's instance by instance. It is person by person who filled out that survey, and house by house. So it has all the attributes that are related to that class. And so you can use it for things like machine learning. So the housing estimates, the housing data set, for instance, has every housing unit that is represented in that survey. And it has, as one of the fields, the estimated household home value, right? And so you can use all the associated attributes that are linked to that household and generate a machine learning. You can do an analysis that where you can predict the household value based on all of those other attributes. So I'm actually going to zoom out a little bit and talk about why I came about the microdata in the way that I did, and I'm going to get into that by talking about open data. So open data science and open data. There's just a massive number of open data sets out there. Some estimates are that there are over 18 million open data sets out there, which is more open data sets than there were web pages when Google was founded. The problem, though, is that the majority of this open data and actually the growth and the acceleration of open data is growing in silos. Right, so individual efforts stand up data portals to address their own needs without a whole lot of thought as to how their data is then going to connect to other data that exists out there. And so you load it in, and then the users come out, bring up their truck, and then take it away to process it offline. Okay? So finding and understanding all this data and using it can be a really big challenge. You basically have out there on the internet this vast warehouse of open data sets. And the best that anybody can do is tell you the name of the data set, a little bit of information about it, and tell you where to find it, right? And then it's up to you to actually take that box, take it down from the shelves, open it up, take a look at it. Is this the data that I want? Is it going to address the needs, my needs? Is it going to answer the question that I want to answer? And everybody does this. This is the current state of the world, right? And so this process happens over and over and over again. Data scientists, data engineers, we all have our own tool chains for massaging data into the place just to get to the point where we can start the real work. And this happens all the time. Like if I have the same question that you have, we're going to both go to the same source files. And we're both destined to go through the same data wrangling process, right? And this is just a massive, frustrating state of the world to me. And it's something that is just this state of the world is leading to massively wasted, man hours out there. So, what if I were to tell you that there's this technology called linked data, and it's been around for a long time, you might have heard of it, and it has well-standardized and hardened technology, and it's actually meant to address this exact problem. And so this actually goes by a lot of names. It's not just linked data. Some also call it the semantic web, and some also call it RDF, or the resource description framework. And so raise your hands if you've actually heard of this technology before. Okay, great. So this is just going to be review for the people who raised their hands. Hopefully for the people who didn't, you'll get a nice little introduction to what this is. So it's basically applying the same architecture as the World Wide Web, but instead of documents, you're dealing with data resources. So every single person, every single concept, every single state can exist in a vast web of data the same way that documents are linked to each other on the internet today. And you don't need code each website doesn't need its own code to tell the browser how to read it. It's in the architecture of the system overall that allows all of these documents to be shared and linked to each other in the same way. So how do we actually do this? What does this exactly mean in practical steps? So the first thing is you have to break your data into atomic facts. And because again, as long as those individual documents are all boxed up, the best I can do is describe that box and tell you where to find it out there on the internet. So we need to have a standard way of representing the individual bits of data that are in each data set. And so these atomic facts are often known as triples, which comes from the breaking statements into subject, predicate, and object. And so I'll give you a little bit of an example here. So Turkey is a country. Ankara is a city. Ankara is the capital of Turkey, right? These are just statements of fact. Well, these can be represented as a graph. And actually, it's a directed graph. You can see the little arrowhead over here. So subject, predicate, object. The subject and the object are nodes on the graph. The predicate is a property of some type that links those two together. So this is those same statements as a knowledge graph. Ankara is a city. Ankara is the capital of Turkey. Turkey is a country. You can see here that Turkey is both the subject and the object of triples. And so the next thing is, it's important to make in linking data is to assign universal resource identifiers to those concepts that are in your data so that we all know what they are, we all know what we're talking about. And really, the way that you do that is just giving them an address. This is a trivial thing. It's just you use http:// so that I can refer to the state, the Commonwealth of Massachusetts, as this address. This is that concept. And my data set can link to it, and your data set can link to it. And then as long as those two data sets are hosted for public consumption, the fact that I have referenced it and the fact that you have referenced those same addresses then makes our data sets link to each other. So here's what the code looks like. This is about the rawest representation. There's a lot of different languages out there for representing this data textually, and so this is an example called n-triples or nt files, .nt files. And so it's like I said, it's the rawest format that you can have. You just simply list the addresses like they're a sentence. So you have DBpedia resource Turkey is of type country. That's what that first triple says. And then Ankara is of type city. Ankara is the capital of Turkey. You can actually make this a little bit cleaner with another format called Turtle, which is a different serialization. That stands for terse RDF triple language. And you just denote prefixes because I don't want to write out those namespaces each and every time that I'm going to use them. So I denote prefixes for RDF, DBpedia, and DBO. If you get more into this, RDF, DBpedia, DBO, these are well-known either taxonomies or resources out there that people are using on the semantic web. And so you would then just refer to them followed by a colon, and then that basically makes the identifiers for each of these resources. So DBpedia colon means http://dbpedia.org/resource/, right? And then followed up with Turkey. So we have Turkey, that's of type country, Ankara, which is of type city, and is also the capital of Turkey. Easy, right? So putting it all together, this is what that knowledge graph looks like. And now, why is this important? What's wrong with just calling Turkey Turkey? Well, there's the bird Turkey, and then there's the country Turkey, right? And so if you're just dealing with a spreadsheet, you're dealing with purely tabular data, and you've got a string of countries in that column. One of them is Turkey. The computer doesn't know what any of that means. It's just reading string values. And it's true that you can pattern match on that kind of that format of data, but there is no inherent knowledge. There is no inherent understanding of what that concept even means. So with semantic technologies, you can resolve those pretty easily. There are two resources at DBpedia, one called Turkey and one called Turkey_bird. They both have the same name, but they're different types. They're completely different concepts, and they both have independent URIs as well. So, since format is pretty important, Tim Berners-Lee, who's the founder of the Worldwide Consortium and the inventor of the World Wide Web, he posits this 5-point scale, and it rates open data by format. So all the way down at the bottom is a PDF. If you just have a flattened PDF that's out there, people can read it, right? But it's actually pretty hard to parse that into something that's usable. Tabular formats like Excel and CSV, those are in the middle of the road. And then he says that RDF, which is where you're starting to use those universal resource identifiers for the concepts that are in your data. And then finally, linked open data, which is when you're not only using those universal resource identifiers, but you're linking them to other data sets that already exist, like DBpedia, like Wikidata, et cetera. The concepts in your data, linking them to concepts in those. And you're making it part of the semantic web by making those connections explicit. That is at the high end of the scale. So that's what I was shooting for. And so why does this matter? So by using semantic technologies to both model and distribute data, you not only make it more usable, but you make it more available. You can use semantic modeling to put the metadata into the data itself, so you don't have this separation between your CSV and your data dictionary. You actually use these technologies to actually say, when I'm querying the data, I'm looking for people who are black, and I'm looking for people who are Hispanic, and looking for people who are white, and I'm writing that in actual words. I'm not looking for any coded values. So you put that information about the data into the data itself. And all this basically gives data users a leg up when they encounter your data and they try to use it. It's also, you see more and more, I would say, articles about this, why semantics and data linking is vital to artificial intelligence. And it's because those linkages at the granular level between resources in your data are explicit in the data itself. This is a ripe opportunity for applying artificial intelligence by using those expressly denoted relationships in your taxonomies. So what I did was develop an RDF schema or ontology or taxonomy. They're all basically synonyms in my mind for the public use microdata survey. And I did that for the years 2014 and 2015. I started when I started, 2014 was the latest year available, and then as I kept going, 2015 came out, so I figured I'd do that one as well. 2016 comes out later this year. So typical census data releases are tabular, and it's pretty easy to make tabular data into a graph. Basically, each of your rows is a subject, each of your columns is a property or a predicate, and then each of the values is an object. And so you can make objects. Objects can be concepts themselves. They can have, like turkey, for instance, was both the subject and the object of triples. It can be a raw value, or it can be a node in another graph. So here's what an example looks like. Housing unit 345 is of type housing. It has electricity cost, this concept of electricity cost, and then that electricity cost is 123, okay? So doing this gives the data some new features. You've got URIs to denote these linkable concepts. You've got metadata built into the data itself, and it's all part of a secure queryable database. So there's this new, beforehand I had 4 gigabytes of raw CSV of this ACS microdata, which was, it's full of coded values. It's full of combined properties. It's full of nested properties where certain properties rely on others. And it's difficult to work with because it has such a high learning curve, right? And it has a high learning curve because you're constantly referencing between the data and the data dictionary. Well, I turned everything into a queryable graph database where it's now hosted thanks to our partners at Amazon Web Service. It's actually one of the public data sets that are available for free to use on Amazon S3, and you can develop one of those cool apps that Alexandra was just showing. These resources are now completely machine readable. And it's also distributed in many different formats, not only Turtle, like the one that I was just showing you, but also an RDF derivative of XML for people who are more familiar with that. And so what I would love is for people to take this resource and to use it, to take this resource and to get into the nitty-gritty, to query it, and to provide applications to the public based on this microdata sample, and to provide knowledge and to hopefully create a more informed public. That's what I hope becomes of this data source. So I'm not going to show it to you because it's a lot like looking at a database, but I'm just happy that this is done. I'm happy that we just launched it on AWS as a public data source, and so that's basically my portion of the program today about the microdata. The next thing you guys might get a better kick out of because it's more. I'll give you examples and I'll show it to you, and it's pretty neat. So then I was alluding to it before, which is it's I think the only way that you can or that you can interactively use ACS data as an SQL database. So to do this, I'm going to go gather my windows. Sorry, just a second. If I can find my mouse. Here it is. Just a second. Mirroring my display. Probably can't see that, so I will bump it up a little bit. Okay, this is data.world. It's actually too big. This is the homepage of data.world. We are a social network that's focused on data collaboration projects. A lot of people come here to search for data that might help them for any of their analyses that they're working on. We're not even a year old, but we already have, I don't know how many Len data sets we have on our platform, but it's, is it in like the tens of thousands? Tens of thousands. And users, how many users do we have? Tens of thousands. 40,000, something like that. I don't know. We're doing well. We're not even a year old, and the informal tagline that I've been saying, don't, Len, cover your ears, is that we're GitHub for data. There's a standard way to go about open source development that GitHub has really led the charge on, and we aim to do what GitHub did for open source for data analysis. So that's how I think of it. So come here, create a profile, host your projects here, any analyses that you're running, and host all your data files, host all the summary, all the insights, all of your charts, all of your visualizations, everything can go right here so that other people can reference it and other people can build on your work, and other people can help you. Other people might have interesting ideas about how you can improve your analysis and want to join you and answer the same question. So we have a couple of marquee data providers. One of them is the Census Bureau. And I'm going to talk to you about the American Community Survey. And you'd be tempted to go to this 2014 American Community Survey link, but that's actually not the one that I'm going to talk about. I'm going to talk about all of these data sets that start with ACS 2015 5E. And there are a lot of them. And I think that there's something like 16 of them. And so I'm going to go into this one called Foreign Birth. And why is it ACS 2015 5E? I'm going to first go over that naming convention with you guys. So every time you go to a data set on data.world, there's this rich summary page where the people who've hosted this data set can write a summary, give you a little bit of an intro into it, how to get started. Down here, you've also got a list of files. Every one of these data sets has 58 files. And they're all the same structure no matter which data set you're using. There's a README file, which I highly recommend you take a look at. There's a table key and a column key. Those are metadata files. And then there's one file per state, as well as DC and Puerto Rico. And then there are 3 USA files. And the USA files are, one of them is for the full USA in geographies that are larger than states, so regions and divisions and things like that. There's another one, there's this all states file, that's purely there for convenience. You could, I decided to put that in there so that you wouldn't have to do a federated query across every state file. And then there's the ZICTA file. Alexandra was talking about this. The ZICTAs are in USA because not all zip codes are wholly contained within states. Some zip codes go beyond states, which is fun. So, why is it called ACS 2015 5E? It's a standard nomenclature, a naming convention that I came up with because it allows us to expand the information, or expand the number of data sets that we're going to provide in partnership with the census. ACS refers to the data product. 2015 is the reference year. So for multi-year releases, that's the last year of the release. So 2011 through 2015 in this case. 5 is the period covered. So 1 would be a 1-year file. 5 is a 5-year file. E is the measure. So E is for estimates, and M is for margins of error. And then there's the topic area. In order to get population estimates out of these, it's actually pretty simple. It looks big and scary when I look at one of these files. Let's go to the smallest state, just so it opens relatively quickly. It might look big and scary, but it's just 2D data. You've just got population estimates by geography. And so these are summary levels. Alexandra, did you cover summary levels? Maybe a little bit. So 40 is the summary level for a state. 50 is the summary level for counties. If you're an experienced census user, you will know about these. If you're not experienced, you'll get comfortable with them pretty easily. The thing that I've done with these summary files is I've pre-geocoded them. So we're looking at, there's no data up here in these entries because we're looking at the Wyoming state overall. So the FIPS code for Wyoming is 56. Going down here, we're starting to get into the counties. So there are county FIPS codes. So that's every county in Wyoming. And then going down to places. Remember, there are some difficulties with places, Alexandra would tell you about, depending on if it's New England, New York, or New Jersey. And so places in Wyoming, we've got Aftontown, Auburntown, etc. CBSAs, this is what the gentleman was asking about before. If I can scroll all the way down. So the metro areas are found in these CBSAs. And then all the way down at the bottom, which you can't see because I'm covering it with, there we go, is the congressional district. There's only one congressional district in Wyoming. Okay, and then the data, those are the geocodes. When you get the summary files, by the way, straight from the census, all the files are stored just with the data itself, with no geocodes and no information, no metadata at all. So I wrote an assembler program to do that for the user and hosted these here. And so these are those variable IDs that Alexandra was talking about. So B05001 underscore 001, what is that? Well, you can either look it up on FactFinder. You can click the little information button here. This is nativity and citizenship status in the United States for the total population. And then number 2 is for US citizens. Number 3 is for US citizens that were born in Puerto Rico or US island areas. Number 4 is US citizens born abroad. Number 5 is naturalized citizens. And number 6 is not citizen. So let's take a look at this in a different way. The table key will tell you what kind of information you're going to look at in each of these topic areas. So B05001, that's nativity and citizenship status in the United States. Number of columns over here is 6, et cetera, all the way down. It gets much more granular. So something like sex by age by nativity and citizenship status Asian alone. So that's going to give you population estimate for male versus female within certain age brackets, whether or not, and for Asian people only, and across those 6 different columns. So you're going to have a permutation of several columns. So that's 23 different columns that are contained in that one table. And so to figure out which specific columns you need, you come to the column key and you will see those column metadata records that I was showing you before that, from the information button. But a better way to do this is to open the query tool. So I included these metadata records as machine-readable files so that you could query them yourself. And so this is just selecting everything from that table key and ordering by table ID. This one is going to just show you all the different columns that are in the data set. And so let's say, for instance, I want to find the number of citizens, naturalized citizens, and non-citizens for a given zip code. I'm using here data.world zip code 78731. So this is the zip code. I'm taking it from the USA ZICTA file, where ZICTA equals 78731, and I'm selecting these columns, right? Easy enough. If you need to see what the columns are, you can click that little information button. You can also give them aliases. So here we're looking at ZICTA 78731, where I have a little over 22,000 natives, a little over 1,000 naturalized citizens, and a little over 2,000 non-citizens. You can also select by summary level. So this is, I'm from Texas, so we're using Texas examples. I'm using the Texas file where summary level equals 50. 50 is the summary level number for counties. So this is basically going to give me all the native citizens, naturalized citizens, and non-citizens for every county in Texas. Okay? And then, this one's just an order by because it was out of order before. Now I'm going to select using some string matching. So Houston, that's where I'm from. So I'm including where area name like Houston. And so Houston County. Houston's actually in Harris County, so I don't actually know where Houston County is. There's South Houston City. Here's the metro area. the gentleman before was asking about. So Houston, the Woodlands, and Sugar Land, Texas metro area. And then Houston City, that's where I'm from. Okay? And then you can also do a multi-table select. So I'm going to select every town or county or just area name that includes Riverside from these states. It's running. The reason I chose Riverside, little known fact, is Riverside is the most popular name for town in the United States. It's actually not Springfield. I thought it was Springfield, but it's not. So you have Riverside Town in Alabama. You've got, let's see, we've got a lot of them in California. We've got one in Connecticut, one in Georgia, and one in Texas. Okay, so you get it, right? This is a new way of interacting with the census. Previously, you would have to do something like go to Fact Finder, or use the API. Go to Fact Finder, and I would look up B05001, and go, and click here. And add geographies. I want counties for Texas. Yes, all of them. Okay, and then it comes in this format, and then it actually goes way. So then you'd have to transpose your columns, you'd have to clean it up, you'd have to remove these margins of error, and then you'd have your file. So hopefully, by including this SQL functionality, it enables you all to get at it a little bit more quickly. Another cool thing is, and I have a demo of it under my, if I can find it, join to census data example. So I have a CSV here, which is just one column. The one column is all the zip codes that are in Travis County, which is the county where Austin, Texas is. So these are just zip codes, one column, that's all it is. Because everything that is ingested on data.world is automatically ingested and translated into a graph database on the back end, you can upload CSV files, Excel files, tabular JSON files, SQLite, and a lot of other formats, and we will automatically ingest them, and you can query across those with SQL regardless of their format. It also makes it very easy to join to other people's data on data.world, including the census. So, launch the query tool. Here I'm using kind of an old school join, where I'm taking Travis County zip codes, that's my file, and I'm taking the zip code column. That's the only column I've got. And I'm taking this one, which is the median age column, from the age sex data set from the US Census Bureau, where zip code is equal to ZICTA. So all I had were the zip codes, my own zip codes, in a file. And using this quick little query, I was able to take the median age for all those zip codes. And this is within my own data set. This isn't in the census's data set. Now I'm going to do another join across two data sets, where I'm adding not just the median age, but also the number of males from 18 to 24 with less than a 9th grade education. So I'm using the education data set, also using the USA ZICTA file from that data set, which is also part of the US Census Bureau, and I'm giving them aliases age, sex, and education so that I can use them up here in the select, and I'm just saying where zip code equals ZICTA and zip code equals ZICTA. So now I've added that column to my data. Okay, so you can see that this is a new way that you can parameterize these queries and really quickly get the population estimates that you're looking for. And you can do it within your own space in data.world. And then all you have to do, if you want to take this and process it offline, once you've done your kind of wrangling on our platform, is, let's say, I'll choose R this time, because why not? I'll just drop this into a script file, post that there. And here's my data frame. There it is. So you're off and running. You've loaded into an environment, the statistical environment that you're more friendly with, and you're off to the races. And then you can do all sorts of machine learning that you may want to do. So that I think pretty much caps off what I wanted to show. Let me just make sure in my slides. Yep, that's pretty much it. Okay, yeah, so we're at the point where we can take questions. Yes? Gentleman with the, yeah, gentleman with the green, Israel.
So, thanks, first of all. I've used American Fact Finder, no offense, but wow. Less painful. So, I can also upload my own data sets into data.world and do like zip code or Zicta matches, right?
Yes.
Using that SQL. Okay, cool.
Yes, for sure. And it doesn't have to be just with it could literally be any data file that matches the value in your file to another. It doesn't necessarily need to be zip code. It could be something else even. But yes, there are some data sets that are already on here that do give crosswalks between like FIPS codes and so like data.world is quickly becoming a place where a lot of people are collaborating with the same issues. These kinds of typical data wrangling issues that you might come across, that I come across, chances are you're gonna find someone with a solution. And if there isn't yet, put it up there yourself, and then help everybody else in the community out. Yeah. Yes, in the back.
So, based on your naming convention, I'm assuming that you are also intending to slowly build an archive over time.
Yes.
When you get a new data set, you're not overwriting the old one, you're getting a new one.
Right.
Now you have two instead of overwriting the old one.
Right. If it's at the data set level, and you need to make an update, any of these files, I kind of made the analogy to GitHub before.
Yeah.
If I can go back to the one that I was on, ACS.
Well, let's just say for the 2015 one that you pulled out.
Right, this one.
Yeah, I guess if there are corrections to that data set that get published,
Yep.
you would correct this data set?
Yes, that's right.
So, have you given any thought to, rather than having somebody search to see which one has the newest date, to have essentially like a mapped pointer to this is the most current set, and that most current set pointer changes to whatever the most current set is?
So there are a couple ways that you can go about that currently, and then there's the future question. Right now, if I need to update this data set, and I just drop in another file that is ak.csv, it will automatically update and overwrite this other one. The previous one will be saved. Actually, it's not like when you delete a file at data.world, you're not actually deleting anything, and that's going to lead to version control, forking. I'm going to branch your data set, work on it myself, and send updates back to you, and you can review them. That whole thing. And so that's part of the answer. The other part of the answer is it's always this URL always points to the most updated data. All of these queries are running on an endpoint. Each data set that you create and you upload any files, we're spinning up a graph database instance that is an endpoint that you can hit remotely with any apps that you build. And the final piece that I would say is I could make at US Census a big, broad American Community Survey, and then it would point to all the data sets that compose it along with the most updated ones.
Right, so just to make sure I'm understanding, so you'd always get, because of the GitHub nature of this, you'd always get the latest, what we're looking at, the latest 2015 Alaska.
Yes.
And the latest 2016 Alabama and all that stuff. But how does someone know that 2016 has come out and that 2016 is now the most recent set?
Well,
We're always looking at 2015.
If you follow the U.S. Census Bureau account, I'm following them. You'll get updates of new data that come in. So that's the first thing. The second thing, yeah, it's purely dependent on the release schedule of the census itself. So as soon as they come out with 2016 information, I will run it through my pipeline and post it right up, and then the people who follow the account would get that update. Yes. I'm not sorry. It's really hard to hear you.
So I'm saying, in the future, do you see this as any sort of integration point to public blockchains like Ethereum or?
Yes, and that's I don't know. Len over here is in charge of partnerships, and he can maybe speak to some of them that we're currently working on. But yes, and I think our philosophy, as a big broad statement, is we want to make the largest, most abundant, most collaborative data resource on the planet, and we hope to play nice with everybody, essentially. I know a lot of people are interchanging. We're still got some time. Yes.
Actually, it's funny because I'm from Houston too, and I was
Fantastic.
interested in that
H-Town, what's up?
metropolitan area you showed Houston. So, yeah, it was kind of. But my question is, so you showed that example when you can input data directly to R.
Yeah.
And that was some sort of like address, like web address, right?
Right.
But to get that, you first have to run your query in this.
Not necessarily. Not necessarily.
Directly.
No, there is. So if you go to docs.data.world and go to SDKs and connectors, you can look at the R SDK.
I was just like wondering if like there is a direct way of doing it in R.
Oh yeah, for sure. So you can just go straight into, you would go to Advanced, get your API token, copy that, put that into a file on your root directory, and then you're pretty much up and running. You would have to install, you'd run this command right here. Yeah, to install that package, and then you can run queries directly from R.
Are there any limitations in terms of like how many polls per day or like per hour? Or?
There are, but I don't know what they are. Yes. And I mean, if we notice that you're hitting us like a lot, we would probably reach out to you like, hey, who are you? What would you like to do? We can increase your limit, but if you're trying to scrape us, like, you know. Any other questions? Yes.
That's a question for Alexandra. Has there been any thought into collaborating with the USPS on people who move or shift to track the shifts in the demographics in certain areas?
I can't speak about all the partnerships and all the talks that we have been doing out there. The only thing I can tell you is moving towards 2020, there is a talk about looking closer at administrative records, other records out there available from federal agencies and programs that we can utilize to increase the quality of our data. That's all I can say so far.
Anybody else? Any other takers? Yes.
Can I pull this into Tableau?
You can. You can. There is a Tableau connector as well. I don't actually. I've never even used Tableau myself. Yeah, chat with Len about it. I know Tableau is a great tool, but I don't know. I use R and Python.
Which you can use in Tableau.
Yeah, you can. I mean, they're all connected. They're all connected at this point. Any other questions? Okay, great. Thank you, everybody. Thank you so much. Hopefully you can use Census to enrich your analyses and save the world.